So thanks so much to Alon and Laura for organizing this. The title of our tutorial is Price Theory with Indivisible Goods. So to put things in context a little bit, we're going to be talking about competitive equilibrium in markets with indivisible goods. I want to start out with this quote from the famous book of Maskell, Winston, and Gray, which is that the most substantial assumption for the existence of competitive equilibrium concerns convexity. So it's usually assumed and kind of needed to assume that something like that preferences are convex in order to guarantee that prices can clear markets. And that assumption is basically incompatible with the indivisibility of the goods that are traded in the market. Now, why do we care about indivisibilities? It's because in many applications, they play an important role. So for example, if you think about settings where people are exchanging goods, those goods are often indivisible. So for example, in a market like the housing market, most people buy 0 or 1 houses and don't really buy fractions of houses. So the indivisibility that people don't really buy fractions of houses, and it's important because most people buy 0 or 1 houses. And similarly, in the market for used cars, you don't usually buy a part of a car, and most households would buy, say, 0, 1, or 2 cars. Maybe more, I guess, in some cases. Indivisibilities are also important in auctions. In auctions for radio spectrum or auctions for ad slots, the items that are being sold are indivisible. Indivisibilities also arise in assignment settings where courses or school or slots at school are something that people either get or don't get. They also arise in labor markets where people either take a job or don't take a job. And when you're thinking about sufficiently specialized jobs, firms may hire very few workers who are doing the job. So it's kind of important to both sides, the indivisibility. And indivisibilities can also arise in production when you think about specialized enough inputs and machines. So the outline of this tutorial is first, I'm going to talk about price theory. So when equilibrium exists in settings with indivisible goods where there's money and people have utility that's quasi-linear money. So I'll start by reviewing the classic theory that builds on this growth substitutes condition. And then I'll talk about a new approach that Alex and I have been developing based on preferences, thinking about preferences over bundles of goods. And this is based on in preparation paper of ours titled The Economics of Equilibrium with Indivisible Goods, which we're now committing to put on the archive by July 1st. And then Alex will talk about the equilibrium existence beyond the quasi-linear setting. So both in settings with real money and settings with fake money. I should say we'll post some version of these slides in a couple of days, too, along with links to the working papers as they're posted. So let me start by talking about the quasi-linear setting. The fixed idea is, let me just set up a simple model. There'll be a finite set I of indivisible goods and money in the market, which is going to be the numeraire. So money, the price of money is 1. And there's some finite set of agents. And each agent is going to have a valuation for indivisible goods defined over binary vectors of dimension the number of indivisible goods. So here the implicit assumption is that people either buy 0 or 1 unit of each indivisible good. And this valuation can take value in the real number, in the real line. And there's also it's going to give rise to a demand correspondence, which specifies that a given price vector, which specifies prices for all the indivisible goods, what the agent would demand. And this demand correspondence is just a solution of a utility maximization problem, where the agent maximizes over all bundles X of indivisible goods, the value of the bundle minus the price of the bundle. And the price of a bundle is just a dot product between the price vector and the bundle. So I should say the assumption that people each demand at most 1 unit of each good is not essential. I'm just making it here to keep things as simple as possible. And also, please feel free to interrupt me with questions, comments at any point. And each agent is also going to have an endowment of indivisible goods, which is also one of these binary vectors. And what we're going to be thinking about is competitive equilibrium. And what a competitive equilibrium consists of is a price vector that specifies a price for each indivisible good, as well as a consumption bundle, which specifies for each agent J some selection from their demand at the price vector P, such that the market's clear. So the total of the consumption bundles that people get must equal the total endowment of goods there was in the economy. Okay. So what we're going to be thinking about primarily is under what conditions on these valuations a competitive equilibrium exists. So I want to start by talking about classic theory based on the substitutes condition. So I want to first give an example of why equilibrium can fail to exist in the indivisible goods setting. So let's say that you have three agents in the economy. There's going to be a seller who has an apple and a banana to sell, and they value them both at 0. Then there's going to be two agents who don't start out with any indivisible goods, but are looking to buy some indivisible goods. The first agent, J1, is going to value the pair of the apple and the banana at $4, but isn't going to value the apple on its own or the banana on its own. This agent sees the apple and the banana as perfect complements. There's also going to be a second agent, J2, who doesn't exactly the opposite, just values the first piece of fruit they get at $3 and the second at 0. So the agent sees the apple and the banana as perfect substitute. So for interpretation here, you could think of J1 as some agent who wants to make a smoothie, and J2 wants a snack. So what could equilibrium look like? Well, there's a unique efficient allocation of the indivisible goods in the economy, which is that if you give both the apple and the banana to agent J1, that will generate a social surplus of $4. And there's no other way to get a social surplus of $4 or more. So if there's going to be an equilibrium, this has to be the allocation of indivisible goods in it. But I claim actually that this allocation cannot be supported in equilibrium. So why is that? Well, if we had prices at which the market's cleared, and this were the allocation of the indivisible goods that resulted, for the agent J1 would need to be willing to buy both the apple and the banana. So they'd have to prefer getting the apple and the banana over buying nothing. And for that to happen, the sum of the prices of the apple and the banana has to be at most 4, because this agent values the bundle of the apple and the banana only at $4. Now, J2 isn't getting any fruit. And so in order for J2 to actually be willing to forego their snack, each piece of fruit needs to cost at least $3. And these two conditions are incompatible with each other. If the apple and the banana each have a price of at least 3, then the sum of the prices of the apple and the banana must be at least 6. There is no way to clear the market here. And so there's no, to be a little bit more precise about this, there's no way to find prices that are going to support this efficient allocation in equilibrium. And because equilibrium allocations have to be efficient, that tells us that there are going to be no competitive equilibria in the example. So the way that the classic theory has been able to obtain existence results, well, ultimately we need to rule out, at least rule out this example. So what's intuitively driving the non-existence of equilibrium in this example is this inconsistency between whether the apple and the banana are complements or whether they're substitutes. Agent J1 sees the goods as complements, and agent J2 sees the goods as substitutes. So one way to rule out this inconsistency between whether the goods are going to be substitutes or complements is to just require that all the goods are substitutes. And that's the approach taken in the seminal work of Kelso and Crawford. But to be a little bit more precise here, let's say the two goods I and K are substitutes. If whenever the price of good I falls, that always weakly lowers demand for good K. So if you make I cheaper, people may substitute from K to I. The way I formulated this condition is asymmetric in I and K, but it turns out it's actually asymmetric. And what Kelso and Crawford showed is that if all goods are substitutes, so all pairs of goods in the economy, then competitive equilibria are guaranteed to exist even when you have indivisibility. And there's a large literature developed on understanding algorithms for finding equilibrium and the structure of equilibria under this substitutes condition. I'm not really going to talk anymore about that. I just want to point out that in practice, though, complementarities are often important. So for example, in the spectrum auction setting, a telecom company may want to assemble a nationwide, to be able to, a way to provide nationwide coverage. And that's going to require a bunch of different spectrum licenses, which are then going to be complementary to the telecom company. And more generally, I think in any setting with production, you would expect that some inputs are complements. You only will want to buy one item that's involved to produce something if you can buy the other items that are also required to produce that product. And these complementarities are completely ruled out by the substitutes condition. It turns out, though, that the case of complements is much more complicated than the case of substitutes. So when you go beyond, when there are more than two goods in the economy, the case of substitutes and the case of complements are not symmetric. And it turns out that if instead of requiring that all goods be substitutes, you require that all goods be complements, equilibria are not guaranteed to exist in general. But nevertheless, equilibria do exist for some patterns of complementarity. So I want to talk about, in the remaining, I guess, of about a half hour, is how we can think about what patterns of substitutes and complements are compatible with existence by looking at people's preferences over bundles of goods rather than over goods themselves. Let me start out by giving you one of the basic examples of why the presence of complementarities can cause trouble with equilibrium existence. I think this should illustrate why there's a fundamental difference between complements and substitutes when you go beyond the case of two goods. So this example is going to need to have three goods. There's going to be a seller again who's going to sell, who has an apple, a banana, and a coconut available to sell. And the seller values all of the goods at 0. And there's now going to be three agents, which are going to be kind of symmetric with each other. So the first agent is going to value the pair of the apple and the banana at $4, and isn't going to value anything else. So it's not going to value the apple and the banana on its own, and it's not going to care at all about whether they get a coconut. You can think about J1 as wanting to make this smoothie. J2 is going to be exactly the same, except they're going to want to buy the banana and the coconut. And again, value that at $4. And J3 is going to want to buy the coconut and the apple and value that at $4. So here the structure of efficient allocations is a little bit more complicated. So there's multiple efficient allocations. But in order to produce, for there to be positive social surplus, one of these agents, J1 and J2 and J3, needs to get two pieces of fruit that they want. Right? Otherwise, no one's gotten anything they want, basically. So let's say J1 gets two pieces of fruit they want. So this apple and the banana. My claim is that no allocation where J1 gets the apple and the banana is actually supported in equilibrium. So if I can show you this, we can then conclude that there are no equilibria in the example. So why is this the case? Well, if J1 is going to be willing to, for that agent to be willing to buy the apple and the banana, the apple and the banana cannot be too expensive when you put them together. Right? So the price of the apple plus the price of the banana has to be at most the agent's value for that bundle. So at most $4. But now no one values a coconut on its own. And so that tells us that the price of the coconut has to be 0. Right? The only way the price of the coconut could be positive is if the coconut ended up being purchased by someone who actually valued the coconut. But J2 and J3 don't value the coconut on its own. And neither of them is getting the apple or banana that they need to value the coconut. We can conclude that the coconut would have to have price 0. But now J2 needs to not want to buy a banana. And you keep in mind that this coconut has a price of 0, so it's available for free. So J2, if they can get the banana for less than $4, they're going to want to buy the banana and take a free coconut. So this tells us that the price of the banana would have to be at least 4. And similarly for J3 to not want to buy the apple and take the free coconut, the price of the apple has to be at least 4. But these conditions are not compatible with each other. Right? If the price of the apple and the price of the banana are each at least 4, then the sum of the price of the apple and the banana has to be at least 8. And then J1 is not going to want to buy the bundle of the apple and the banana. So our conclusion here is, again, that there are no competitive equilibria. This example might feel very different from the previous example I gave you of non-existence of equilibria. Because here, everything is complementary to everything else. There's no conflict or inconsistency between whether goods are substitutes or complements. So what I want to argue to you is that actually, if you look at things more carefully, there is a conflict between whether things are substitutes or complements. But you can only see that if, rather than thinking about goods as what's being transacted in the economy, you think about bundles of goods as what's being transacted in the economy. So let's say that rather than apples, bananas, and coconuts being what people buy and sell, there's a bundle. The bundle is in blue. And that bundle consists of an apple and a banana. And in addition to buying and selling the bundle, you can also buy and sell apples and coconuts separately. So if you want to buy just the banana without the apple, what you need to do is you buy the bundle and then you sell the apple in it. And you end up with a banana. Ultimately, forming this bundle and making bananas not be transacted on their own doesn't change anything about the economy. It just changes how things are packaged. So let's think about what happens, whether the apple, banana, and coconut are substitutes or complements. So let's suppose that the price of the coconut goes down. If the price of the coconut goes down, then the second agent who likes a banana and a coconut may say, it's time for me to start making my banana coconut smoothie. I guess maybe it should be banana and coconut water smoothie for that to make sense. But J2 is going to, at some point, may say, it's time for me to start making a smoothie. Let me also start buying a banana if the coconut is cheap enough. But if you buy a banana, in order to buy a banana with this bundling, J2 has to buy a bundle and sell an apple. So if the price of the coconut falls, agent J2 may start selling an apple, that is, buying less apples. And so when you bundle the apple and the banana, that makes the apple a substitute for the coconut for the second agent. But the apple and the coconut still remain complements for the third agent. So here, now that we've bundled the apple and the banana together, there's a conflict or this inconsistency between whether the apple and the coconut are substitutes or complements. So actually, once you think about things in terms of bundles, the second example of non-existence of equilibrium with pure complements is actually a special case of the first example, where there's an inconsistency between whether goods are substitutes or complements. So I see I have a question, which I'm
It was me
not
making not very clever remarks about the divisibility of coconut water. Sorry, Ravi, please keep going.
okay. In my experience, coconuts are divisible in, no, they're not. Usually you buy coconut, like fresh coconut water, you get the whole coconut. Yeah. So I would argue that in some sense there's some indivisibility there too, but we can discuss this another time. So that brings me to the second part of my part, which is I'm going to talk more generally about how bundling, looking at the structure of whether bundles of goods are substitutes or complements, is going to be able to tell us whether equilibrium exists, even in settings where all goods are complements, or there's combinations of substitutes and complements. So I guess I want to start out by just introducing some terminology for preferences over bundles that I kind of used implicitly in developing the example I just went through. So we're going to need to think about a bundling, which is which combinations of goods are being transacted as the primitives. And what this is it's just some set of integer vectors that's a basis for the space of all consumption vectors. So the idea here is that ultimately you can buy whatever you wanted to buy by buying or selling these bundles. And given any combination of bundles, so a vector of quantities transacted could be positive or negative of the bundles, that's going to give you a consumption vector where it's defined by adding up over all bundles the amount of the bundle you buy times the vector of goods that's in the bundle, which is just by combining whatever you're buying and selling in that vector Q. We can also think about demand for bundles. If these bundles are the primitive objects, then they are going to be what's priced. So we can think about a price vector, which I'll denote by P tilde, which specifies a price for each bundle. Then demand for bundles is given by maximizing over all quantity vectors of these bundles that correspond to binary consumption vector. The value of the consumption vector that you get minus the price of the bundle, or the price of the combination of bundles. And what's the price of the combination of bundles? It's just a dot product between the vector of price of the bundles and the quantity of and the quantities of each bundle that you're buying and selling. Now we can then think about whether bundles are substitutes or complements. So given some bundling and two bundles in the bundling, we say that the bundles are substitutes if lowering the price of one always weakly lowers demand for the other. So lowering the price of B can only make you substitute from C to B. The bundles are complements if lowering the price of B always raises demand for C. So if B is cheaper, then you may think, oh, I want to buy more of both B and C. And the bundles are consistent if they're either substitutes or complements, not some mixture where some people see them as substitutes and some other people see them as complements. So what I want to get to is I want to say that if some bundles are consistent, that's going to be necessary, it's sufficient and essentially necessary for equilibrium existence. But in principle, there's like a lot of possible bundles you could consider, many of which have no relationship to agents' preferences in their car. Like you could think about just bundling apples, bananas, and coconuts as all three when no one really wants all three. People only want two of them. And I think that wouldn't make a lot of sense. So our idea is that the relevant bundles to think about are combinations of goods that are all mutually complementary to each other. Now, there's a subtlety, which is that if goods are substitutes, if we just thought about when good, there wouldn't be any bundles, and that's not really the right thing to think about. So what it turns out is that if you have two goods that are substitutes, there is actually a hidden complementarity inside, which is that, say, an apple or a banana are a substitute, then an apple is complementary to the opportunity to sell a banana. So if you kind of flip the sign of the banana, you're going to uncover a complementarity. So when we think about bundles, we're not just going to think about complementary goods, but we're also going to think about goods and opportunities to sell the good that complements. So our bundles are not going to be positive combinations of goods. They can involve negative amounts of goods as well. And the way that we measure what bundles are complements is going to be something relating to preferences, and it's using this concept of price effect. So what a price effect is it's just a change in someone agent's demand that comes from decreasing the price of a good. So you might say, well, I lower the price of one good. That means I increase demand for two other goods. So like I is complementary to K and I is complementary to L. Now, why does it make sense for me to bundle all three of these goods? How do I know that the two goods to which I is complementary are not themselves substitutes? It turns out that in the indivisible goods setting, that can't happen. So if you take a price effect for any agent that comes from lowering the price of some good I, and let's say that that price effect has positive components for two other goods, K and L, then it turns out that those goods are not substitutes. I don't claim this should be an obvious statement. I don't think it is. It's actually not true in the divisible good context. But the point here is that when I see a price effect, if that has positive components for a bunch of goods, those goods are all complementary. So the way that we're going to think about what bundles are relevant is by using this concept of price effects. We say that bundle is relevant if it's either a price effect or just an elementary basis vector. So an elementary basis vector would just correspond to one unit of one good, so as if there's no bundling. The non-trivial bundles that we are calling relevant are the ones that correspond to price effects, with the intuition that these are bundles of goods and sale and opportunities to sell goods that are all like mutually strictly complementary to each other. And we say that some family of valuations is bundle consistent if for each bundling that consists only of relevant bundles, every pair of bundles in the bundling is consistent. So this is it's refining the idea that whenever you have two goods, they must either be substitutes or complements. This is applying that, it's applying that same condition, not only to goods, but also to bundles. And also regardless of how everything is, how all other goods are bundled, as long as the bundling doesn't involves things that are relevant to the agent. So our main result is going to be that bundling is sufficient and essentially necessary for existence of equilibrium. So the first theorem is that if all agents' valuations are bundle consistent, then competitive equilibria exist. And I also want to argue, in a sense, that bundle consistency is necessary for equilibrium existence. I think we could kind of see it through the example, where if you have a pair of goods that some agent sees as substitutes and some other agent sees as complements, there's kind of an obstruction to equilibrium existence. But it turns out that in order to make that statement, make that intuition precise, we need to make sure that there's enough flexibility in what valuations in the economy can be. So I'm going to call a domain of valuations invariant if it's closed under the addition of positive linear functions. So if some agent has some valuation, you add to it any positive linear function that has to stay in your domain. And second is this domain needs to contain the zero valuation, where you don't value any bundle at non-zero. You assign non-zero value to any bundle. We can then show that if you have some invariant domain such that competitive equilibria exist in all economies when all agents have valuations in that domain, then the valuations in this domain have to be bundle consistent. This is a sense in which, provided that one is working with a class of references that satisfies these two conditions, so that's closed under addition of lots of linear functions and contains the zero valuation, bundle consistency is in fact then necessary as well for equilibrium existence. So let me pause here for questions for a little bit. So far I talked about what happened when agents demanded at most one unit of each good. And it turns out that when you have multiple units, there's some other issues that arise, which is that if you think about two units of the same good, there could be an inconsistency between whether those units are substitutes or complements. So in addition, inconsistencies across goods, you may need to worry about inconsistencies within the same good. So in the multiple unit case, we need to introduce this unit consistency condition, which requires that units of the same good always be substitutes. It kind of doesn't really make sense if units of the same good are complements, because these are basically representing the same thing. And it turns out that unit consistency plus an appropriate extension, this bundle consistency condition, are sufficient and essentially necessary for existence of equilibrium. So the point here is that when thinking about equilibrium existence with indivisible goods, beyond the case of substitutes, we're able to show that the economic structure of substitutability and complementarity between bundles fundamentally determines whether equilibrium exists. So there's this idea that when you have goods that are substitutes sometimes and complements at other times, that's a problem for equilibrium existence with indivisible goods. We're able to show that when you apply that same logic to bundles of goods, as well as to units of the same good, in addition to being essentially necessary for equilibrium existence, this consistency condition, but consistency between substitutability and complementarity becomes sufficient for equilibrium existence as well. I think there were far fewer questions than I was planning for. So I think that is all I have to say. And maybe Alex, you can recapture some of the time.